about it over here. Okay, I just had a technical difficulty, so I was trying to pick up exactly where I left off. We just talked about it over here, that 4 times negative 17 equals negative 68. So negative 68 divided by 4 gives us negative 17. No, we are not surprised. Where is my chalk? I lost my chalk while I had my technical difficulty. Boy, I really lost my chalk. Here it is. Okay, now to finish with what I was doing before I was so rudely interrupted by my technology, equals negative 12. 5 plus negative 17 is negative 12, so we end up with negative 12 equals negative 12. Doesn't matter that it's a weird number like negative 12, no. When the number on the left is equal to the number on the right, it means you verified. The verification worked. It means that our algebra worked. Negative 68 was indeed the correct answer. So there I am. Okay, I can see where I am. I no longer can keep an eye on the time as easily because I had to start a new recording. But I'm not going to worry about that because everything was pacing very well in this lesson. And I only have a few examples left. So, negative 10 equals x over 4 minus 2. I'm glad we're doing a lot of practice of ones like this. Okay, the first thing I want to do is get rid of the minus 2, the negative 2, the 2 that's being subtracted from this fraction that has my x in it. So the opposite of subtracting a 2 is adding a 2. If I'm doing that over there, I have to do it on this side as well. These cancel. We have x over 4 over here, and negative 10 plus 2 is negative 8. I want to isolate my x, it's being divided by a 4, so I do the opposite, I multiply by a 4, but what I do on the right side I have to do on the left side. These cancel, x is equal to 4 times negative 8, which is negative 32. Does that verify? I won't write it out. Negative 32 divided by 4 is negative 8. Negative 8 minus 2 is equal to negative 10. It verifies. The verification is great because whenever you're doing this, you're always able to check whether you're right by doing your verification. And if you realize there's a mistake, you get a second chance. Some types of math put you in that position where you can check your own work and then fix it if there's a problem. And that's a really good thing to have. That's a great tool in the toolbox. Okay, next one. Erasing. Negative 3 equals x over negative 2. Oh, this time there's a negative sign with the number that's in my denominator. Does that matter? Well, no, it doesn't. So long as we follow the rules of algebra, we're going to be able to handle that. Minus 9. We have lots of negative signs in this one. Okay, but all I care about is what my first step is. I want to get rid of the minus 9. I'm doing the opposite. I'm going to add a 9 to both sides. If I'm subtracting a 9 here, I am subtracting a 9 there. These cancel. I have x over negative 2. Negative 3 plus 9 is positive 6. And my x is being divided by a negative 2. So it's being divided by a negative number. Is that a problem? No. I'm going to get rid of that by multiplying, doing the opposite. I'm going to multiply by negative 2. I'm multiplying by, not just by 2, by negative 2. So I'm multiplying both sides by negative 2. The negative 2's cancel. Negative 2 times 6 is negative 12. We have our answer. Can we verify? Negative 12 divided by negative 2 is going to be positive 6. And 6 minus 9 is indeed negative 3. It verifies. It works. It keeps on working because it's good. The algebra tricks we are learning are good. We will use them again and again and again and again and again and again for the rest of our math careers, and that is good news because we're good at it, so we should want to have to use it again and again. How about negative x over 3, this time the negative sign's up on the top, plus 2 equals 6. I'm just going to worry about the plus 2 for now. So negative x over 3, I'm not touching it. But if I'm adding a 2, I want to do the opposite. I want to subtract a 2. What I do on the left side, I do on the right side. I'm subtracting a 2 on both sides. These cancel. Negative x over 3 equals 6 minus 2, which is 4. Now I kind of have a choice. Do I want to deal with the negative sign and the 3 separately or together? Well, actually, I do have a choice. There's more than one right way of doing it. Okay, I want to get rid of the 3. I'm going to worry about the negative sign later. So I'll get rid of that 3, which is being divided from my negative x, by multiplying both sides by 3. These cancel. I still have negative x. My x is still not isolated. 4 times 3 is 12. I turned a 2-step into a 3-step because of this choice that I made, but am I afraid of a 3-step algebra? No. I'm not afraid of a 522-step algebra. Not really, although it would take quite a lot of chalkboard wall. Okay, negative x equals 12. I'm not finished. My x isn't isolated yet. I need to divide both sides by negative 1. That x is having a negative 1 multiplied by it. The opposite is dividing by negative 1. These cancel. X is isolated. 12 divided by negative 1 is equal to negative 12. I have my answer. And now I'm down to my last problem. I'm checking the time. I'm thinking that I'm not going to add a 19th problem. I'm going to do the 18th, and then we're going to be done. Okay. Erasing. Four minus x over 4 equals 4. Lots of 4s. I just felt like I wanted to have a lot of 4s in my next example. What am I doing first? I'm not going to worry about all this. I'm going to worry about this 4. And this 4 is being added. It's a positive 4. It's being added on this side. So I'm going to do the opposite, which is to subtract a 4. That minus sign stays with this. I have to keep it. If I don't keep it, I am introducing a mistake. Since I am subtracting a 4 on the left side, I am subtracting a 4 on the right side. These cancel. I have negative x over 4 equals, 0. Oh, I got a 0 and I wasn't finished. Should I worry? I'm not worried. I'm going to trust the skills that I've learned. My negative x is being divided by 4. I want to do the opposite, so I'm going to multiply both sides by 4. I can multiply 0 by 4. I know how to do that. These cancel. 0 times 4 is 0, though, and I have negative x equals 0. Am I finished? No, not really, although I can kind of see what's going to happen. And I might want to just jump to an answer, but I don't want to. My x is being multiplied by a negative 1, so I'm doing the opposite. I am dividing both sides by negative 1. These cancel. X is alone. 0 divided by negative 1 is still 0. Any fraction with 0 as the numerator is equal to 0, even if the denominator is negative. So I have x equals 0. Will this verify? 4 minus 0 over 4 equals 4. Well, 0 over 4 is equal to 0. 4 minus 0 equals 4. It makes perfect sense. It verified. It was weird, but it verified. Why did I survive this weird situation that looks so weird in the second half of the problem? Because I trusted the steps that I've learned. I've trusted my algebra methods. Subtract a 4 from both sides if you need to. Divide both sides by a 4. Multiply both sides with both sides by a 4. That's what I did. If you need to. Divide both sides by a negative 1 if you need to. So long as you're doing on the left side what you're doing on the right side, you're allowed to do it. It's algebra. And it got me the right answer. So really, there's no downside to this. One thing I'm going to do differently at the end of this is something I always do in my teaching. I always have my fizzy water, but I've never actually finished the video with the ah. So that's what I'm doing this time. Watch the finger in the mouth. Oh, and thank you very much, and I'll see you next time. This was fun, like usual. Time flew by because it was so fun, but I'm thirsty.